Alright, here we go. It is 13.1, right triangle trigonometry, day 6. And for this final day, we are now going to be solving right triangles of any type, not just the special ones from the last couple of days. So our goal is to solve for every missing side and angle, and if any of them are decimal values, we're going to round those to the nearest hundredth as needed. Okay? So go ahead and take a look at our example here. We see we've got a right triangle. Looks like one of the other angles is labeled 28 degrees, the other angle is blank. And of the three sides, we have sides A and C unknown, but we have side B labeled equals 15. So knowing it's a right triangle, knowing one of the other angles, and knowing one of the sides, we're going to be able to find everything else. Let's go ahead and start with angle B. It's the simplest, easiest little bit to get out of the way here. For angle B, well, we know the angles of a triangle have to add up to 180. And if I right away get rid of my right angle, and that's 90 for sure, get rid of it, the other two have to make 90. So if one of them is 28, I can take away 28 from 90 and find that the other one must be 62 degrees. So right away I've got angle B right in here is 62 degrees. Now moving forward, to solve for either side, A or C, we're going to use some of the trigonometry from the last couple of days. And that means looking at the angle that we're given. Now technically we could even use the 62 now that I found it. For our purposes I'm going to stick with the 28, but it really wouldn't matter at this point. And using the angle I was given, 28 degrees, using the side that I was given, I look at how they're related, and I realize this is an adjacent side. If this is the hypotenuse, and if I'm looking at this angle, that's the opposite side. So I know this is an adjacent side. Now, I choose one of my unknown sides. Do I want to solve for C, or do I want to solve for A? I'm going to start by solving for A. We'll get to C eventually. So now I look at A and I see that it's the opposite. So I realize that I want to solve the opposite side, and the one I can use that I know is the adjacent side. Now I start thinking opposite, adjacent, and I'm reminded of tangent, which is TOA, opposite over adjacent. So this allows me to now basically write an equation that says the tangent of 28 degrees, it's no longer just a theta, it's not some angle we don't know, it's a specific, the tangent of 28 degrees equals, and it's the opposite side across from 28 degrees was A, over the adjacent side next to the 28 degrees was 15. So we're going to solve this equation by multiplying by 15 on both sides. Now something to note real quick about the tangent of 28, that is a constant value. Because these triangles are all proportional to each other, even though some of the sides could be bigger, some could be smaller, the idea is if it's a right triangle and if it's 28 degrees, that value is fixed. An easy one for us to see and confirm this is using sine. So you're going to have to use a calculator for some of your work today. If you have a calculator on your phone and turn it sideways, you generally get a lot more options that aren't there when it's held vertically, so then it becomes more of a basic 4-function calculator. But if I turn it this way, I get lots of other functions. Or you can go to Desmos.com, use their scientific calculator. You can do it that way. But as far as trig values being constants, let's take a quick look at the sine of 30 degrees. And you'll notice the sine of 30 degrees is 0.5, constant. And so think of what we know about a 30, 60, 90 right triangle. Across from the 30 is the number 1. And remember, sine uses opposite over hypotenuse. So opposite is 1, the hypotenuse is 2. It's 1 over 2, or 0.5. And remember, there could be a bigger triangle. Maybe it would be 4 over 8. Maybe it would be 10 over 20. No matter what it is, though, it's always going to come back to a ratio of 0.5. So tangent of 28 is no different. And that means I can solve for A by doing a times by 15 on each side. And I get A all by itself equals, and now I have to type on the calculator, 15 times the tangent of 28. So go over here and do 15 times the tangent of 28. I get 7.97, and then it continues 5, 6, 4, and on and on. But I know from earlier I said we were going to round to the nearest hundredth, so I'm going to go ahead and do exactly that. I can also make these lines wavy at this point the moment we do tangent 28. We're now estimating some stuff here, and I'm going to go with about 7.98. So I'm going to come on back up to my diagram, go to side A, say A is about 7.98, and now I'm going to do this one more time with my focus being on the letter C. Now again, at any time you could use the 62 degrees if you wanted. In fact, you could even use the 7.98 now that we know it, though it's an estimate. It's not as exact as the 15 that's down here. So for me, just to keep things simple, I'm going to keep it all about the 28 we were given and the 15 we were given. But again, as you learn new information, you could also use that new information to set up your trig ratios. So I'm now looking at 28 degrees is still my theta. I'm still using this adjacent side, but I now want the hypotenuse, and I'm thinking adjacent hypotenuse, AH, and I'm thinking of cosine, because cosine is the ratio of the adjacent side to the hypotenuse. So in this case, I'm specifically taking the cosine of 28 degrees, and I'm setting up a ratio where the adjacent to 28 is 15, over the hypotenuse, the unknown value C. Now, this isn't quite as easy to solve this time, because instead of multiplying by 15 and getting A alone right away, we have to multiply by C, move things to the other side. You could have done this with a secant. Remember, secant is the reciprocal of cosine, and if you used secant of 28, then this would be a reciprocal. You'd have C over 15. You can check the book and see that they did it that way. I'm going to stick with this and show that we can get there anyway. So I'm going to do a times by C on each side. This cancels. I get C times the cosine of 28 degrees equals 15. And then ultimately, now if I want the letter C all by itself, I'm going to divide by the cosine of 28 degrees. And once I do that, C is by itself, and it is approximately, go back to that calculator, and I'm going to type 15 divided by the cosine of 28 degrees. And it looks like 16.98855, and it keeps going. And again, following my own directions from earlier, I'm rounding to the nearest hundredth. So I find the hundredth place, I look at the thousandth place next to that, I decide to round up. C is about 16.99. And now I can go back to my original diagram, label C is about 16 and 99 hundredths, and check and confirm that I've got all three angles and all three sides. So we solved the entire right triangle using trigonometry there. That's it. You can now go ahead on your last assignment. It's page 857, numbers 23 and 25. Thank you very much.